Good morning. We often come across the term design of central AC and design of chiller. So, what exactly this design term means when we are talking about the role of engineers in industry, especially in HVAC industry, heating, ventilation, and air conditioning industry. There, if you are employed as a design engineer, so what exactly this design would mean, even if you are not employed for that matter, it would be a good idea to understand what the design term would signify. So, the objective of the short video is to introduce you to the concept of design of central air conditioning plant. You see two terms being displayed here. One is the central air conditioning and second is chiller. So, what is the difference between these two? Central air conditioning system is basically a system where the air handling unit and the refrigeration unit is placed at some distance away from the load, and then there is an elaborate ducting system which would carry the conditioned air to the load. By load, I mean the rooms. For example, if you are talking about a central AC system of a hotel, then in a central AC system of a hotel, you would have a refrigeration facility placed somewhere. There is the air handling unit, and the air handling unit would have ducts. The ducts would be carried to the different rooms. A chiller is also a central AC system, but this is a central AC system of a special type in the sense that you use a piping system to carry chilled water to the load. There is exchange of heat between the chilled water and the air handling unit at the room. The chiller system is used if the load is higher. For example, if you are having a 400 TR load, 400 tons of refrigeration load, in that case, it is not feasible to have a ducting system, or it would be rather inefficient to have a ducting system for the entire 400 TR right from the refrigeration room. So what we do is that you have a chilled water arrangement. A chilled water would carry the cooling effect to nearer to the load, and then there is an exchange of heat between the chilled water and the conditioned air, room air rather. So it means that in the chilled water system you have an additional fluid, namely the chilled water. So how do you design a central AC system and a chilled water system or chiller? So the outcome of the lecture is, at the end of the lecture, you would be in a position to appreciate how exactly a air conditioning system or a chiller tonnage is arrived at. So by the term design, I will be restricting to the capacity of the chiller. There are many other things in the design aspect. The students would be able to understand the role of design engineers in air conditioning and chiller companies. That is the outcome of the lecture. Scope is I am restricting my discussion to summer air conditioning system. Summer air conditioning means the temperature outside obviously is higher and you need to cool the air. And if it is a humid climate, then we also need to dehumidify the air. So the scope is summer air conditioning and I am dealing with hot and humid climate. In that case, the chiller would be a coil in which refrigerant flows, and this refrigerant would reduce the temperature as well as humidity of the ambient air for conditioning. The system design would also include the duct design, the duct layout, fan selection, pump selection, but that is not the scope of the lecture. So by design, we would be discussing only the selection of the capacity of the refrigeration unit or the cooling coil in terms of refrigeration. So that is what I had said, that the scope is only the coil selection and not the duct design or fan selection or pump selection. So chiller sizing means what capacity chiller or what capacity AC I should buy from the market for a given load, say hotel load or a hospital load or a mall load. In that case, three important things are to be understood. One is what inside conditions I need to maintain so that the people inside the mall or the theater are comfortable. So this is known as the inside design condition. The second is which day I should choose for doing my load calculations. And third is what is a load calculation. So these three things will be discussed in brief. This is just a photo of chiller. It's a York made chiller. This is another photograph of a chiller. So we are talking about designing this cooling coil, or rather selecting this cooling coil. So this is the load, that is the room which is to be conditioned. Ti and Rhi is the inside temperature and inside humidity one has to maintain. This room would experience an increase in the temperature in summer if there is no air conditioning. The reason is there would be occupants inside this room who would contribute to the load. There would be load from outside which would result in the increase in the temperature. There would be load from outside which might increase the humidity in the room. There would also be factors increasing the humidity inside this. So all this would lead to an increase in temperature and humidity, and the occupants would feel uncomfortable. That is the reason we need to have a cooling coil or AC apparatus. So what this cooling coil would do is that it would supply the conditioned air to this room. So the design question is at what temperature should one supply this air so that the occupants feel comfortable? What humidity one has to maintain for this supply air? So this is the design question. This schematic is drawn without ventilation, means we are not introducing any fresh air inside this room. So the design conditions which would influence the tonnage would be what temperature and what humidity one has to maintain. So what decides that? So there is a science to it. It is called as a heat balance of an individual. So just as you have a heat balance of an engine in which there is a source of heat generation and there is a source of heat dissipation, similarly the human body can also be considered as a heat engine in which heat is produced by metabolism, and then there is a heat exchange with the surrounding by means of convection and radiation. And also there is some useful output in terms of work which we do, the human body does. So this is, as a result of this, the human body has to be maintained at a certain temperature. If he or she has to feel comfortable, then this would be happening only if the balance is proper, the heat balance is proper. And for the heat balance to be proper, you need to maintain a particular temperature and a particular humidity. Now what temperature and what humidity, that is already researched by professional bodies like, for example, ASHRAE, American Society for Heating, Refrigeration and Air Conditioning. They have done a lot of study on this parameters, like what temperatures and what humidities human beings feel comfortable. And this is not a static or one point parameter. This is a range of temperature and range of humidity under which human beings feel comfortable. So the design condition, indoor design condition, means you need to choose the appropriate temperature and appropriate humidity to be maintained at a particular location for a particular application. So this is called as an inside design condition. This is one of the design parameter. The other parameter which would be useful is what is the load on this system. So this load on this system has to be calculated, and there is an elaborate procedure to it which would influence the design, that is the capacity of the chiller to be ultimately selected. The third is what are the outside design conditions. So the outside design conditions means which day of the summer, which hour of the day, what temperature and what humidity I should consider for doing the load calculations. Now these things, okay, for example, why are they called as design conditions? The reason is, if I choose, for example, if you are asked to do a sizing of air conditioning system in winter and you do the calculations by taking the ambient temperature in winter, then your AC system, which is designed for a day in winter, would not serve the purpose of air conditioning in summer. Or even if you take one particular day of summer when the temperature is lower, the humidity is lower. In that case, if you operate that AC system for some other warmer day, then that AC system would be not capable of removing the load, or you won't be feeling comfortable with that AC system. So there is a science to it, and it is called as the outside design conditions. So how do you choose the outside design conditions? How do you choose the inside design conditions? And how do you do the load calculations? These are critical things in your design of AC system. So in the next video, we would be seeing how to select the inside design conditions, how to select the outside design conditions, and a brief discussion on load calculations. Thank you. Meet you in the next video.